Hi and welcome. This is the fifth video in the lathe restoration and upgrades video series. So in this video I want to finish closing all this area in, which I didn't really get time to do in the last video. And then I want to work on the electrical side of it. So I want to put a on-off switch probably around about here, maybe in line with the wheel center. And then above that, I want to put the emergency stop button that'll be on this panel here. So that'll be over there somewhere. It's kind of a long switch, so I've just got to make sure it's not going to get tangled up with the belts and pulleys, which it won't. So that'll go there. And then I want to install the RPM gauge or tachometer over here somewhere, and that'll be on that panel as well. To finish closing in, I need a piece at the back, which I'm going to use some MDF wood. So that's why these bars are sort of offset in from the edge here. So it will be flush with the sides, the back and front sides here. Then it's just a matter of a panel here, a piece across the top and a panel down the back. Now the piece across the top is important because I'm going to be putting a spindle lock attached to this piece at the top that will come down and interact with a piece of steel that's fixed to the spindle, and that will also act as a indexing mechanism as well, so I'll be able to put it in specific positions for indexing. Also, that plate will support, along with this bar, they will support a bearing at the back here so that the spindle is supported. So that is the goal in this video. Let's get to work. Here I am marking out the MDF board. That gets cut to size just with a skill saw, or what we call a skilly. I test fit that in there after cleaning up a bit for the welds, and that fits in there quite nicely. Now, there's a lot of drilling and tapping in this video. I drill and tap all these holes at the back and just test fit screwing that board on, and that works great. This piece is for the top, and I cut it a little bit longer so that I can mark it out on the MDF. I'm just working out here where the angles need to be cut. Those corners get cut off. I just use a handsaw there. And I just clean it up a little bit with some sandpaper. Now I'm just marking off how long I need this piece, and that is cut off as well. That top piece needs to be secured, so here is some 12mm square bar that I use for some brackets. It's clamped on and then welded into place. I work out where I need to drill for the mounting holes. And those are drilled in the drill press, and then I'm using those holes as guides for the threads. This is 30mm by 5mm flat bar. And this is used for the MDF end of the housing. I need to use this because I need to be able to get the pulley sheaves in, and with the square bar it would not fit. I'm just welding on another piece of square bar there, and also these side bits. I've got to be careful not to weld that front panel on. I check that the pulley sheave can be fitted in there without any issues. Then I drill and tap the square bar so that this top plate can be bolted on. Now I'll work on the back side of the housing. This is just a piece of 1mm panel steel. I was going to use my vice press brake to bend it, but the bend is too close to the end, it won't work. So instead I score it with the grinder, and then I use some angle iron to bend it in the vise. And this actually works quite nicely. I make a second bend and I just do a little bit of knocking into place there. And then that piece fits on there like that. Now I've drilled some holes in here. I use them as guides. And then I'm able to drill and tap the holes to hold that panel on. And that is held on by 4 screws, and that part's done. Now I need to make a bracket to hold the bearing for the spindle. So there's 2 pieces here. The small square stock gets welded in place. I then drill and tap 4 holes to hold that piece on. Now there will be a hole that gets drilled in the middle of this piece, but I'll do that once I build the new spindle. The next step is to actually mount this bearing onto a plate that gets bolted onto the plate behind it. Again, I don't have any stock big enough, so I have to make this out of 2 pieces. A bit of flat bar and a piece of round stock. The round stock is cut, and then that will be welded on there. And the round stock will be bored out to suit the bearing. I clean up the round stock. And I sort of mark out where it's going to sit inside the flat plate. And then I can bore that out. So this is bigger than 25mm, which is the spindle shaft. Also score a line on there so I can line up this round stock again. That is clamped in the vise, and then I can weld that onto the plate. That is then drilled out and bored out so it's a press fit for the bearing. Now I found a new bearing that is the same size, so I'm going to use that. And we just press that in with the vise. That fits on to the shaft, which is good, and it will actually get bolted onto this plate at the back. I'll do that when I have built the spindle, so I can line everything up properly. The next step is to build a spindle lock, which will go about here. Now it's getting a little bit tight, and I only have about the width of my ruler here, which is about 1 inch or 25mm. If I need more room, I can also move that set screw back a little bit and then turn down the sheave. I drew up a plan last night for the 24 divisions, which are 8mm holes, and I need a diameter of about 80mm to fit those 24 holes in. So I think I'll get it out of this piece of plate here. This is the widest piece of steel I've got, which is 13mm. I mark it where I need to cut it out, and then I do that with the grinder as my plasma cutter still is not working. Then you sort of end up with a kind of a round piece. Let's put in the forejaw, and it's bored out. And now I'm working on the shaft that'll go down the center. That is pressed in there. And then I weld it on the other end. Now I forgot to put a center in the shaft when I had it in the lathe last time, but luckily I have this machine part at the back that I can still dial it in. This sounds a little bit like a wood lathe where you make a square piece of wood round. Once that surface is round, I clean the face off. And then I start drilling the centre and then boring the centre out to the right size, which is 25mm. I can't part that off in the lathe, so I cut that off with the grinder. And then that fits on there like that. Of course the spindle will come right through here. But I did find an issue, and that is the round stock that I use was probably a little bit too small. You can see the sheave has a bigger piece, so I might have to make a sleeve that goes over the one that I've just made. That will give the grub screw more meat to screw into. And that is exactly what I did there. I turned up a ring and pressed and welded it on. Now I'm drilling out and tapping for an M8 grub screw. Now I've set up in my spin indexer and I'm milling out the 24 evenly spaced holes for indexing and locking the spindle. That's another view of the other end of the spin indexer. This is the last hole and I'm pleased that it's all lined up nicely there. So that piece goes on there, and the bearing and the back cover. This is how this all goes in here, and I've just got enough room to fit everything in here, so my calculations worked out pretty good. Anyway, the pulley sheave goes around about there. Then we have the indexing wheel, so that's just hard up against the pulley sheave. And then the bearing is at the back here. Now I haven't bolted this bearing to the back plate. I'm going to do that when I replace this spindle shaft, and then I'll have one piece of steel. At the moment, all I've done here is I've just extended the spindle with a piece of steel, just sort of the right diameter, but it's not exactly perfect. So I'll work out where this needs to be bolted once I get the spindle shaft done. So the next step here is to make some sort of detent that can go into these holes, and then that will pop through the top here, so I'll be able to turn a knob and it will drop into one of these holes to lock the spindle. And also there's 24 evenly spaced holes in here, so that can be used for indexing as well. Now I'm going to start working on the detent mechanism to lock the spindle. I've looked in my box of springs and I think this is a good spring that will work for this mechanism. So I basically designed the mechanism a little bit around the spring, you know, working with what I've got. Including the spring, there's 5 parts. There's the body, there's a cap, there's the locking rod, and there's a knob. The knob actually screws on to the end of the locking knob up here. Now I've seen companies do this 2 different ways. The Nova lathes by Technitool have the spring sort of at the top here, so the plunger or the locking rod is always pushing down, always wanting to be engaged into the disc with the holes in it. And it has some mechanism at the top where you have some locating pins and you can actually lock it open. The other way is having the spring at the bottom where the tension is always pushing the locking rod away, and what you do is then you push down on the knob to engage the locking pin or locking rod. And I guess the disadvantage of the Nova way, where it's always pushing down, is if something malfunctions there, then the rod is going to want to go into the holes when the lathe is spinning, and that's not a good thing to happen. And I guess the disadvantage of the other way, where the rod is always pushing away from the holes, is that you need to put pressure on the knob to lock it in. But that's not useful for when you want to do indexing, where you need to lock the chuck and work on your workpiece for an amount of time and then move it to another position and work on it again. And I've seen some people use blocks of wood and magnets to hold the knob down or engaged, and you know, making up all these other ways to do it. So that's what this little 6mm locking pin here is for. That's so that you can actually push down on the knob and then turn it, and it will stay engaged. So sort of get the best of both worlds there. So anyway, it's just a kind of a plunger design, probably don't need to speak too much about it. So let's get into building it. So I start working on the body. This is 32mm steel bar. And that's turned down to 20mm initially. And I don't have a M20 die, so I single point thread this part. And that nut fits on there nicely. Now I do have a die for the M18 for the end where the cap goes onto, so that is threaded. I drill the centre out to 12mm and also parts of it out to 14mm for the spring. Now I work on the cap. That has a 8mm hole drilled right through it. And then I'm cutting the M18 thread here to screw onto the body. And that fits nicely. Now I'm drilling a 20mm hole in the top. This is where the main body will go through. And this is how it all fits together. I start working on the locking rod, and this is turned down into several different diameters for different parts. So where it locks into the indexing wheel, the inside diameter of the spring, and also the part where it screws into the knob at the top. I assemble that up and test it out, and that works very nicely. Now I start working on the knob, and I start with knurling the outside. And then I sort of taper this in a little bit here. I have to take the inside out to fit over the body. And I'm just cleaning up the centre hole so that can be threaded out to M12. Put a couple of chamfers there. Now I am threading the locking rod for the knob. And that fits on there nicely. This is where it's different to the plans. So the roll pin is actually put into the body here. So I drill a 3mm hole and press that roll pin in. Now I have to cut out the slots for the roll pin to come through the knob. Now we assemble it all up. And this is how it functions on the machine. Once that is all done, I wanted to add some strength to the stand. These are cross braces that go at the back of the stand. I drill them out to 10mm for 10mm bolts, and I use my homemade radius jig here to round off the ends. These are angle brackets that I've welded to the legs, and I bolt on that brace. Now I'm marking out where to drill the hole for the other end. I do that all off camera and then bolt that brace on. And I do the same for the other diagonal, and now I'm drilling a hole in the centre so they can be bolted together. That is how the brace looks. Now you'll see down the bottom I've put some ankle brackets down there as well. They are for a platform if I need to add one to the lathe at a later date. Once that's all done, I'm going to start working on the electrical side. This is the main switch for the motor, and that's going to go there. I mark that out and I draw the mounting holes and the centre hole for the shaft to come through. That gets screwed on to the front panel. Above that switch there will be a panel that has the emergency stop and the tachometer. So I start that off on the 3D printer. And while that's printing, I'm welding on some lugs that 3D printed panel will need to bolt onto. So there's one at the bottom and there's another one at the top here. So they're drilled out and tapped so that the panel can be screwed onto the front. The printing is complete, so I assemble up the panel with the emergency stop switch and the tachometer. And then that is bolted onto the front of the lathe. On the other side we have all the wiring. This is the main cable that comes from your wall socket, and that will plug into those terminals you see down the bottom there, which is a no volt release switch. This is the main wiring loom. At the top it has the emergency stop switch, which I'm screwing in. Below that is the blue motor on off switch. And below that is the 12 volt power supply, which runs the tachometer. That main wiring loom comes down to the bottom here and fits into this bracket and goes out to the motor. Now I didn't film any of this because our wiring here in New Zealand might be different to other countries. Also, I am not an electrician, although I've taken precautions here and I've made sure that I have really good earth connections. I've crimped and soldered all of my terminals on, and I've used heat shrink insulation around them. But basically the power comes in, goes to this no volt release switch, then it goes up to the emergency stop switch, and then it comes down to the motor on off switch and also feeds the 12 volt power supply, and then it comes down to the bottom and goes out to the motor itself. So once all that wiring is done, I work on the sensor for the tachometer, and I've made up this bracket that holds the sensor. And I've just clamped it in place. I drill some holes and this bracket gets bolted on. It needs to be bolted on so that it can be removed so that I can get the pulley sheaves in and out. Once that is all wired up, I test out the tachometer. I'm just turning the spindle by hand because I have no pulleys and belts in there at the moment, but that all works fine. The next step is to pull it all down and paint it. Well, that is the wood lathe practically finished apart from the spindle, which I will build in another video. And let me get back to you about why the spindle wasn't turning there. I'll bring you in for a closer look. Pretty pretty much everything is the same as it was before I painted it, although I have blued the handle and the top lock here, and I went to a black cover here instead of the grey one that I had initially. I don't know if you can see it on the camera, but the finish here wasn't too good on the 3D printing. So it's always a challenge to work out what colour to paint things. I went for the grey for the lathe as it was originally, or maybe this is a bit of a darker grey, and the motor is the same there. So I went for the black on the stand, pretty common colour for stands I guess, and the box housing here I went for a maroon colour. You know, the black switches and stuff and the sort of dark handle here makes it look quite nice, I think. The end of the lathe here has been covered in with some MDF, and I've just painted that black, and I've put a hole in the back there. That's for the spindle to come through when I make it in the next video. Around the back of the lathe I've got this sheet metal panel that I made up earlier, and just painted that black as well. As you saw earlier, I made these cross braces at the back. That was just to give it some support. Without them, the legs are only held on by the 2 bolts at the end there. I don't know if this was entirely necessary, but I thought while I was working on the frame and doing all the welding, I should just weld some brackets on and make these cross braces. Now I'm sure you're all very eager on watching me fire up the lathe and actually turn some wood on it. But as I was putting this all together, I was just testing it out, and I had a major malfunction with the lathe. There was a bit of a bang, and then this fell out the bottom. Yep, that's the bottom pulley, the one that's on the motor. So what's happened here is the motor shaft is actually broken clean off here. Now I knew that was a kind of a long distance here and a lot of strain on the motor, especially with this bigger spring in here which holds the belt quite tight. So there's a lot of pressure of the belt pulling this these pulleys up, and of course that's putting a lot of load on that shaft there as well. And I did intend to return another piece here that has a step on it for a bearing. So similar to what I've done for the spindle bearing, just a bit of end support there. But I didn't really get round to that. That was probably going to be in the next video as well. But unfortunately that motor shaft is broken clean off, so I cannot run the lathe and show you how it works. And I've just finished wiring that motor up, and it's got the bracket with the hole spacing to suit the motor that's on there, so I'm going to have to find something that is similar, I guess, that will be suitable. Well, this setback is quite disappointing, as I really wanted to get the lathe up and running and make something. But as they say on Galaxy Quest, never give up, never surrender, and I will strive forward and troubleshoot and fix this issue. If you found something useful in this video, please click on the like button. And if you want to be notified when I release new videos, you can subscribe and click on the notification bell. I hope everyone has a great day, and thanks for watching.